Now. All right, so let's look at some announcements here. The budget limitations assignment is due before class on Friday. And remember, that's just a single question. I noticed that a couple of people have already turned that in. It's just one problem. You probably got an email about a mental health day on Friday, and the university is suggesting that if it fits with the schedule, that instructors can cancel class. And I did review our schedule, and I think it would probably just create more stress than it alleviates if we canceled class on Friday. You're not going to feel less stressed if I'm rushing through material and just trying to cram it all into future lectures in order to make one day off on Friday. So what I'll say is, if you feel like you want to take Friday off, by all means do. The lecture recording is posted on YouTube and on Blackboard, and so you can always come back to it when you feel like you've got the time. I fully support students occasionally taking a break, and I think back to times in my career when I just kind of turned off the lights and went home early. Sometimes you got to do that to stay sane. And so if that's the case for you on Friday, then I don't take attendance, and you can just catch up with the material when you're feeling up to it. So we will have class on Friday at our normal time. Homework 12, break-even and payback analysis, is going to be due next week on Wednesday. We're going to start talking about that material today, and then also the reminder about the project due on Friday the 20th. Okay, so we're going to talk about price, demand, and break-even today, and this is some material that isn't covered extensively in our textbook, and so there isn't really a chapter in our book that covers it in the same depth that we're going to be doing it in the class. But you do have access to the notes, and we're going to go through it in the lecture with the in-class exercise, and so I think you have plenty of supporting resources. Black Friday is going to be a little bit different this year than it has been in the past. And I think actually that Walmart is going to be spreading Black Friday out over several different weeks, because what they want to avoid is what you normally associate with Black Friday, which is big lines. Look at all these people standing close together, infecting each other with whatever virus was circulating at that moment. It wasn't COVID, but somebody in this line had the flu or a cold or something and was passing it around to everyone else. You have to work at Best Buy on Black Friday? Brutal. Brutal. So these are really low prices. At least they were at the time. Now you can get an even better TV for less money. But the whole point of Black Friday is to try to kick off the holiday season and get people excited about shopping. And the main point that I'm making in showing you this advertisement and the lines is that when you operate a retail establishment, the way that you control demand, or the way that you stimulate demand, is by lowering prices. It's the best lever that you have to increase consumption, is reducing prices. And so that's the relationship that we're going to talk about, some of the implications and consequences of the price-demand relationship. Now, the internet has really kind of turned a lot of this on its head, because retailers like Amazon are able to compete against brick and mortar establishments without having to pay for the same retail space, the same staffing, and so they are able to undercut some of the traditional retailers. And you may remember that Toys R Us used to be one of those companies that sold toys, and maybe you have fond memories of going there when you were growing up, but at least the one at the Huntington Mall doesn't exist anymore, because they were undercut by Amazon. So price demand is what we're going to be focusing on, and price we think of as an independent variable, and that means that a company can control the price that they sell their items for. Now, of course, that doesn't mean that they can set any price they want and remain profitable, because if you sell something for less than its production cost, then you're effectively losing money. But in the relationship between price and demand, price is the independent variable and demand is the dependent variable, meaning that it responds to the price, that the people who form the market are going to buy or not buy materials based on the price that's set. So you could probably fill in the blanks here. If the price increases, demand will decrease. And if price decreases, demand will increase. Those are the general trends. And of course, this is a simplification. There's a lot of other factors, like if we're talking about an iPhone 3 that's obsolete, it doesn't necessarily matter so much what a retailer does with the price. Nobody would be interested in an obsolete piece of equipment. But the general trend certainly is for an item that's for sale, if there's a demand for it at a certain price, then decreasing that price would increase the number of people for whom the item is attractive, and therefore the demand would go up. So this is kind of a visualization of that trend, and what it shows is that as the price gets lower, that the units of demand, meaning the number of items that you could sell, gets higher. So if you want to sell a lot, you need to find some way to reduce the price. That's what Tesla has been doing. They started off with really expensive electric cars, and they've gradually been reinvesting their profits to try and find ways to reduce the price of an electric car. And as they've done that, the demand for their vehicles has gone up. Sometimes it's linear, like is shown here. Sometimes it would be a curve relationship. But the general trend is that price goes down, demand goes up. Now, when it's linear, one way that we can quantify the relationship between demand and price is to consider the slope of the line. And so this equation, price equals A, some intercept, minus B, which is the slope of that curve, multiplied by D, which is demand. So this is following the form of Y equals MX plus B. You probably remember that formula from high school math or maybe middle school math, Y equals mx plus b, where you're graphing functions. So what this is saying is that if you happen to know the price where there is zero demand, and so this vertical intercept, if you go and intercept this curve with 0 on the horizontal axis, there is some price where no one will buy the item. And so that's what A represents, is the price that you'd have to charge for there to be no demand at all. B is the slope of the curve, and so that means if you decrease the price by a unit, meaning if you decrease the price by $1, then how much additional demand would there be? How many more units can you sell by reducing the price by $1? So that's the slope and the physical interpretation of lowercase b. And then D, demand, number of units sold. Okay, so D, number of units sold, P, the price per unit. And if you want to know the revenue that a company is generating, how much money is coming to them, it's simply going to be the selling price per item multiplied by the number of units sold. So how much they're selling multiplied by the units sold. And so, of course, you want to have a lot of revenue, but profit is more important than revenue. So don't make the mistake of trying to maximize revenue. What we want to maximize is profit. So if you wanted to substitute this price equation into the revenue function, so here remember is P, the selling price for the item. And if the selling price for the item is A minus BD, then we substitute that function here into P, and what we get is this total revenue is A times the demand minus B times the demand squared. So that's just a substitution. Now here is a graphical representation of revenue for increasing amounts of demand. Now let me ask you this concept question. Why is it that revenue is going down if they're selling more and more units? So look at that revenue curve. What the revenue curve is saying is that your revenue is going up as you're selling more and more units. But now suddenly, even though you're selling more of the thing, the demand is getting less. So why would that be?
Because as the demand goes up, it also goes down because everybody already has it?
That's a reasonable guess, but that's not the answer in this case, because what we're saying is the demand is higher. So they're actually selling more and more, but they're making less revenue. Craig says price increase. No, it's not because of a price increase. They got the price lower. To get the higher demand, remember, they had to lower the price. So why is it that the revenue is getting lower as they're selling more and more items?
Since they lowered the price, then their cost per unit stays the same, so their profit per unit goes down.
Exactly right. Very good. Thank you, KC. So what KC is saying is the way they increased the demand, the one lever that they were pulling on is they lowered the price. And so they're selling more units, but because they're selling them for less money, then the revenue is getting less. So Craig got it right now. Yeah, if the price is decreased, then their revenue drops. Yeah. So D hat, what we call this is D with a little symbol over the top, that's D hat. You can find what is the maximum revenue with A. Remember, A was the intercept in this previous curve. So A divided by 2B, where B was the slope of the line. That's how you can find the maximum revenue. Now let's talk about costs, because Casey brought that up. Cost has two components. There are the fixed costs, which don't change based on how many you're selling of an item. And then there are the variable costs, meaning the costs that do depend on how much you're producing. And so variable costs would include things like, let's say a cell phone as an example. So the variable costs would be like the memory, the processor, the packaging, all of the things that depend on how many you're making. Are you making 1,000 phones a month or 1,000,000 phones a month? Well, all of the costs that do change based on how many you're making, those are classified as variable costs. But there may be some fixed costs as well. So consider like the machine that stamps a certain piece of metal, makes it flat. That machine, once you own it, your capital recovery costs are the same whether you're operating that machine 5 hours a day or 24 hours a day. So there are certain costs that are unaffected by your level of production. So another example might be the rent you pay on a building. Your landlord is going to charge you the same rent in your apartment whether you're there 8 hours a day or 24 hours a day. That's a fixed cost. It's unaffected by how much you use it. So those are the two broad categories that we break things down into. Now the variable costs we can break down even further, because there's the variable cost per unit, meaning how much of those costs goes into a single one of the things that's being made. So sometimes they'll do like a teardown analysis on the new iPhone. Someone will open it up and they'll look at what kind of RAM is in there, what kind of a processor, the screen, and then they know the price that Foxconn charges for a certain memory module, or they know what does Samsung charge for a certain size screen and a certain resolution, and they're able to identify what are all the individual component costs that go into a phone. So variable cost per unit just means how much does it cost for one of the things that's being generated in materials and variable costs. And so your overall variable costs for how many items you're making is the variable cost per unit multiplied by the number of units that are being produced. So that's the overall variable cost. And then the profit is what we're trying to maximize. We don't so much want to maximize revenue as maximize profit. And so profit is defined as the revenue minus the cost. It's how much is left over after you've paid for your costs out of the income that was received. So rather than optimizing D hat, what we want to do is find out D star, optimal demand. And that can be calculated by A, which remember is the intercept from that graphical. It's the price at which nobody would purchase an item. Then lowercase v is the variable cost per unit. divided by 2b, where b was the slope of our demand curve. And so optimal demand is what maximizes your profit. And we can also calculate D prime, the 2 break-even points, and that's the lowest number of production that can cover your cost and the highest number of units sold at which you're still profitable. And understanding the break-even points probably makes the most sense if we look at it graphically. And this is a really important figure. You've already seen the total revenue curve, and so this curve already makes sense to you. But let's consider what else is going on in this figure. Okay, total costs include the fixed and the variable. Craig, do you have a question?
Yeah, could you go back to the screen before for a second?
Mm-hmm.
I got it, thank you.
Okay, good. So CT means total cost. Total cost includes the fixed cost. So this horizontal line is the fixed cost. Those are the costs like your rent or capital recovery on equipment. The things that don't change whether you make no units or whether you make a lot of units. Those are the fixed cost. The total cost also includes the C sub V, the variable cost. And so if you're making a lot of units, you're going to have a lot of variable cost. So the difference between revenue and cost is profit. So profit, remember, is revenue minus cost. And so here, the maximum profit, we want to have this line be as long as possible. So down here, this is a profitable operating point. If you sell D prime 1 number of units, you're not losing money. But you'd rather sell D star units because that's where the revenue curve is the furthest away from the cost curve. So consider the slope of the revenue curve. Like right now, the two curves are getting further apart. See how they're getting further apart? Because the slope of the revenue curve is greater than the slope of the cost curve. But right at this point, the two slopes are equal. And that means we've reached the point at which they're furthest away. If we go further to the left or further to the right, then these two curves are now closer together. And so then this is our secondary break-even point. This is the last number of units that we could sell profitably. And if we sell more than that, we're operating at a loss because costs are higher than revenue. And you don't want to do that. And so you want to be somewhere between D prime 1 and D prime 2. And optimally, to maximize your profits, you'd be at D star. Okay, so we're going to get a taste of how to use these equations with an example today where your company is producing an electronic timing switch where we know the fixed cost, the variable cost per unit. Here is a curve that defines the selling price. Here's the formula for optimal demand and the break-even points. And so step by step, what I'd like you to identify is, number one, what's the best number of units that we could sell? So what's D star? And what is the maximum profit that's associated with that demand? And then find the break-even points, D prime 1 and D prime 2, using those formulas. And so the in-class exercise, if you've got it printed, looks like this. I don't have the formulas on it in the same way that I've got them on this slide. Let me see if I can copy that over so that it's visible. Yeah. Okay. So the first thing you ought to do is try and label the variables. Like, what is A? What is lowercase v? What is B? So consider this equation as well as the information that's given here up front and try and calculate D star by substituting in this formula and then the find out what is the maximum profit that could be earned. So find out what's the revenue at that number of demand. So, you know, with a certain number of units sold, how much income are you going to get and what are your costs? All right, so let me pause for a second and let you get started on this, and then I'll show you if you're not able to identify the variables, I'll come back to that. But let me just give you one last look at this. So on this equation, here's the formula. So A is the intercept, and then B is the slope of the line. So seeing that as the form, here is our particular price demand curve for this situation. Okay, so if we look at the form of this price demand equation, the intercept of 180, that means that if you tried selling this timing switch for $180, then nobody would buy it. If you sold it for $179, you'd have at least one person purchase it. But 180 is that price at which finally no one's willing to purchase. And so that is going to be A. The lowercase v, the variable cost per unit, is 83. And then 0.002 is the slope of the line. And so that is lowercase b. So if you want to calculate the optimal demand, then the number of units that's going to generate the best profit is 2425 units. Okay, so any questions so far about that? All right, so now it's asking what is the profit that you're going to earn if you sell D-star units. So if you operate at 2425, then the question is how much revenue comes in and what are your costs. So the first thing that you need to know is what's the selling price that would achieve that number of units sold. And so P is 180 minus 0.02 times the demand 2425. So you're going to be selling it for $131.50. And so the revenue that you'll have coming in, if that's the price that you sell for, is going to be 2425 units multiplied by $131.50 per unit. So you're making $318,000 per year if that is that's the selling price and the number of units sold. We also need to know the cost because the profit is revenue minus costs. So far we know TR, total revenue. The costs include the fixed and the variable cost. So the fixed cost is going to be $73,000 no matter how many we're selling. And the variable costs are $83 a unit, and we know that there's 2425 units, and so $274,275 is the total cost. And so the most profit that you can make in this situation is $44,612.50. All right, I'm going to pause again, and as you work on D prime, type your guess or calculation, your answer, into the chat box when you think that you found the break-even points. And there are two of them. So you'll notice here in the formula it's plus or minus the second part of the numerator. So that's how you get to having two break-even points. Well, we're running low on time, so let me show you the break-even point calculations. Okay, so here's the formula for the break-even points, and so A is the intercept associated with no demand, that's 180. The variable cost per unit is $83. And so A minus the variable cost per unit squared times 4 times minus B, so that B is the slope of the line, 0.02, and then minus of the fixed costs down in the denominator, 2 times negative B. So if you go through the calculations, then what we're going to have is 932 units is the first break-even point, and 3918 is the second. So here's a little figure that kind of summarizes what we've calculated. We had optimal demand, D star, was 2425. Our first break-even point was 932, and the second break-even point was 3918. So I'll leave that up for a moment in case you want to gaze it over or write it down. But that's all the time we have for today. It's 11:49. I don't like to keep you over. Remember that your next homework assignment, homework 11, that single problem having to do with budget limitations, that's due on Friday before class. So feel free to get in touch if you have any questions about that. I'll post the next assignment, assignment 12, which includes this stuff, the price, demand, and those questions. I'll post that immediately after class, and so that you can get started as soon as you're ready. All right, that's it. Hope you have a great day. Bye-bye.